Welcome to the Data Architecture Elevator podcast. Created by Agile Lab, we will explore the dynamic intersection of technology, innovation, and practices in the data space. Our company purpose is to elevate the data management game of companies that want to be data-driven, and this is the goal of this podcast too. For more information and insights, visit our website at www.agilelab.it and feel free to reach out our architects on LinkedIn with your question. Now let's step into the elevator with Agile Lab data architects. Hello and welcome to episode number 8 of the Data Architecture Elevator. Today we are going to explore themes around LLM and privacy. So I'm glad to introduce our guests today, Antonio Murgia, Irene Donato, and Antonino Gargiola. We're going to explore how large language models intersect with privacy, because with great powers come a lot of questions. And let's deep dive into a bunch of questions. So, just to introduce the topic, how do large language models process and store user data, and what mechanisms prevent unintended data retention? And maybe Antonino, you can start and provide your vision about that.
So large language models don't store data per se, but they process data during two phases. During training, they see the training set. So if a company does a fine-tuning on a large foundational model, the models can memorize some of these training data and then spill it out during inference. So this is a risk and means that you need to curate your fine-tuning data set. And then the other case in which you can process user data is when you call the LLM during inference, and you provide the personal information in the context window, which is the prompt of the LLM. In this case, all the information that is provided, for example, in a system prompt, could be in principle disclosed. So this is the first thing to consider when building systems using LLM.
Okay, good. And what are the biggest challenges in making LLM privacy preserving, Antonio?
Well, as Antonio just said, if private data is part of the original training set, it's quite hard to actually make it privacy preserving. This holds both for original training data and also the training data provided during fine-tuning. That's even, let's say, more dangerous with fine-tuning. So if you end up with private data in the training set, the only thing you can do, but even that is not, cannot be 100% trusted, is using guardrails. Guardrails is a generic term that means we are intercepting input and output of our LLM and changing it on the fly. This interceptor, again, it's a very broad term, so they can be simple programs or even other machine learning or large language model. And this is if you have private data on training sets. A good way to make an LLM-based application privacy preserving would be to not use private data in the training set and put the private data on a vector database that is, let's say, used by your LLM application in a RAG pattern. So if you store private data in the vector database, you can actually use, let's say, traditional techniques to avoid introducing in the LLM prompt any actual private data that you don't want to be there. So, for example, if you have a RAG that is customized by customer, and you don't want data from some customer to be in the answer or used by another customer, so you simply tag and add metadata in your vector database and ignore the results that shouldn't be accessed by that user, that will be in this way indirectly accessed.
Instead, if we look at specifically to personal identifiable information, so PII for GDPR or other kind of regulation, are LLM handling this information in some specific way, or it's always a duty of who is building the systems around the LLM to manage PII properly? Irene, what is your vision about that?
Surely we can use reticle augmented generation to store sensible information, and instead of using our data to train the models, we can store our data in a vector database and then make the model retrieve the information when we need it. And we can also allow the large language model to retrieve specific information for specific user, adding metadata when we store the information in the database. And then there are many open source library to filter and add guardrails to filter sensible data in the output.
So basically, you can add a layer where you intercept PII or in input or also in output from the LLM. And do we have some reference tool, Antonino, to implement this layer? What is the most used guardrail tool right now? Or it's something that you need to build by yourself with your specific logic? Is there something out of the box that can be used?
Guardrails.ai comes to my mind because it's a platform that provides many tools for guardrails, so you can pick which model you want to use, and you can start from small traditional NLP models that detects PII, or you can use also larger models in case your task is more complex. So you can adapt it to the use case, the specific use case. For sure, in general, this is a task that can be handled with smaller models that are also faster to avoid introduce additional latency and so on.
Because latency anyway could be a topic because LLM are not super fast in general. So if you add also some other reasoner, so I was wondering maybe if it's possible to have an agent reasoner leveraging another LLM to do the guardrail. But yeah, probably is introducing too much latency to interact with a user. So
yeah, if the use case is interactive, for sure you're adding a lot of latency in that case. And if it's interactive, usually is you have a kind of a streaming response, so you get one token at a time, and this add more complexity in detecting the PII that must be done on the fly. So again, a smaller model that maybe works token by token and it's fast, it's a better solution in this case.
So we said that basically the two situations where you can exploit sensitive information are in the prompt and in the training set. So in which way you can exploit sensitive information from the prompt? Why this is a crucial step to safeguard in your AI platform architecture?
Basically, you need to think that all the information you put in a prompt can be disclosed by the LLM, regardless of the instructions that you put. You can always put some instruction and say, don't disclose the context that I provide above this point, but there is no guarantee that this will happen, especially if there is some adversarial attacker that tweaks the user prompt in order to try to get more information.
In your architecture, on top of the user prompt, you are adding, doing prompt engineering, you are adding more context to improve the efficiency of the chatbot, let's say. That context can be exploited by the prompt itself, right?
Yeah, exactly. It's called the prompt injection, and can be done from some adversarial user, or even just a random user that are using random words, and it could happen. And in this case, you will not be compliant.
And instead, in the other case, so when the sensitive information are in the training set, many companies are trying to do the fine-tuning of models, leveraging their own data. But by doing this, there is the risk of disclosing personal information or sensitive information. So what could be a practical approach to avoid exploiting sensitive information due to the fine-tuning on the company data? Maybe Irene?
Maybe you can use, instead of use the original data, you can use synthetic data. So data that are very similar to the original one, but they have a similar statistical distribution, but they do not have sensible information. So for example, they substitute the names, and you can generate this kind of data with many techniques, like for example, generative adversarial neural network and other techniques. And another way to fine-tuning a model in a way that do not disclose personal data is using distillation. So you have a large models, and that works as a teacher for a small model, and the small model you can train the model in such a way that do not have personal data as output.
And then in that case, so you train the model with the synthetic data, and you keep the real data in the RAG infrastructure, so you can combine both the benefit of retrieving the real data, but reasoning with the fake or synthetic data. That's good. Then I think there are also a lot of business and ethical implications in using a large language model. So also from a GDPR standpoint, Antonio, which are the key legal and compliance risk in using this LLM, and how a company can protect itself by this risk?
First of all, I think that most companies nowadays do not serve a large language model by themselves, because that's very costly. So usually companies rely on external providers of these large language models. And the thing here is that you need to read very carefully the terms and condition that you accept when using their service. Through that, you would understand what they are storing on their hand, how they are using that data, if they are using only, let's say, in your interactions, or they can potentially use in other customers' interactions, and also which safety and compliance measure they take about that data. So, for example, GDPR says data should be should stay within European borders. Therefore, you cannot use a provider that stores data outside of it. That's pretty straightforward. And to just give an example of what these kind of providers can store on their end, for sure, your inputs and your prompts are stored by them. You can see it in ChatGPT, for example. You have whole history of your interaction with it. But what is more subtle, let's say, is that they can use these prompts to train newer models, and so next-gen models. And these, obviously, we will go back to the first question. These new models will have your data in them implicitly. When you've read the fine print of the user agreement, let's say, then you understand what data you can share with them and what data you cannot share with them based on the kind of data you are working with. And the answer here is straightforward, but the implementation is not simple as we stated earlier. Again, you need to use guardrails and block the portion of data that you don't want to send over these providers. Or, as Irene was saying before, you could also try synthesizing that on the fly on some, let's say, cheaper system on your end before sending it to the provider. On the other hand, if you're not using a provider, so you're serving the model by yourself, well, then it's up to you, and all the things we said earlier must be applied inside your architecture, your system. But here you have a lot more control. So if you understand the tools you are using in your system, should be quite straightforward.
And the same is applicable for guardrails, because if you use a SaaS tool to do the guardrail, then anyway you need to be aware of how they are managing your prompts to improve the tool itself. So this is something that along the whole value chain in an LLM architecture must be considered.
Yeah, a chain is weak as the weakest part of the chain. So if you leak at some point, you leak everything.
Okay. At the end of the day, the safest thing is hosting the model yourself. If you have enough use cases to serve internally, it may be also economically profitable, also on top of being safer.
Yeah, even if you are bringing in-house a lot of effort and maintenance, also because you need to upgrade the model, upgrade the hardware. So it's not that easy, in my opinion, without the right competencies and skills to manage that at scale. But probably there is a balance in terms of opportunities and cost. Yeah, so we talked a lot about the importance of using guardrails, and also there are other kind of tools like LLM gateway that can help to do the routing of prompts based on the nature of the prompt, based on the privacy information that they are they are bringing into the prompt. So how can companies what is the best way to leverage LLM and keep customer data secure, in your opinion, Antonino? So if we need to do a synthesis of what we said, what is the perfect configuration to keep the data secure?
I would say that a key component in an enterprise architecture is for sure an LLM gateway. And this regardless of the fact that you're using managed LLM provided by vendors or you're hosting some LLM in-house or on your private cloud. The LLM gateway is important for cost tracking, for authorization, and also for balancing the load, basically. But it's since it's the entry point to all these models, is the perfect point to put guardrails, for example, for PII detection. I will not say that is the only point you should put these guardrails, but as always in security sensitive areas, you should put many checks along the way. But one of the point that is really fundamental to put these tools is in the gateway, I will say.
In the next future, where we will have a distributed architecture with several LLMs, several agents taking autonomous decision and connecting each other to complete their own task. Do you think these guardrails must be placed in within each agent, so you can control at fine-grained level what each agent is doing with sensitive information, or it's more like a general infrastructure that all the agents will connect to do their task? What is your vision? Do we need specialization and integration within each agent, or it's more a global infrastructure layer?
You can think of it. I like to think of it doing a parallel with data quality. Data quality usually is there is some kind of service that the enterprise provides to facilitate data quality, but the more points where you put data quality, the better. And here is the same. For sure, you will have some standard guardrails that all the use case can use, but also you should add some other specific guardrails that are important for your use case, and each business domain should consider this during the design. And regarding the agentic architecture you mentioned, this opens another complexity, because we have seen that the private information travels through prompts. So it's important that you track the flow of this information. So you need to extend the lineage also to track how data flows through the different prompts of the different agents. I don't think there is a unified tool for lineage that bridges the classical lineage we do with the tabular data and the kind of lineage we need in agentic systems. We have a separate solution for the two words, but that will be an interesting development if somebody managed to bridge them.
This is interesting because, the more each agent, or anyway each use case has its own specific problems in terms of privacy, but also in terms of ethical bias. So how these agents are going to take decisions trying to eliminate the classical bias that we have in our society. So maybe Irene, in which way bias are affecting the LLM operation, and in which way we can eliminate this bias from the standard and medium LLM that maybe we are using as foundational model?
The data that are used to train the models are biased because are the data that we find everywhere on the web. So they are biased. They have our normal bias, and also they can. In the past, we see they can generate really malicious response or offensive responses. So then there is a technique that is the last step on building the large language model that is called alignment. Alignment exploit the reinforcement learning framework and teach the models to answer in a way that is more acceptable, so that do not have biases. But of course, we cannot be sure that they are completely free of bias, because somehow this was done with human scoring the responses. So there was a lot of human effort on doing these. There is a lot of human effort on doing this alignment. So we cannot be sure that they don't have. They are completely bias-free.
So in the fine-tuning, you can do this alignment based on your own principle. Maybe if you are a company or a ONG with specific principles, you can do the fine-tuning to align the large language model to your own principles. How you want to take care of customers, what kind of bias you want to have or not to have, that's maybe based on your positioning in the market as well. So I think this is really crucial, because typically when you hire someone, you try to hire someone that is in line with your company culture. If now we are hiring the LLM to do something, we need to be sure that is aligned with our company culture. And the last topic is, in case of leakage of sensitive information or answers that are not ethical in a certain way, who is the responsible? Who trained the LLM? Who built the system on top of the LLM? The end user? Who is accountable for these kind of problems? Antonio.
Yeah. So if you are serving the foundational model yourself, foundational models are given for free, but as all free and open source software, they are as is, so no one is legally responsible. So you are responsible because you're using the model. So the company that's using the foundational model is responsible for whatever infringement the application that uses the model will do. On the other hand, if you are using a third-party provider, probably they have a big legal department that in the user agreement put many lines about that. So I'm quite sure they will never be liable for what their model is outputting, because you are, let's say, in the middle. So it's up to you. You have to prevent this kind of stuff because you are responsible for it.
So on one side, if you leverage a third-party model hosted somewhere else, but you are intermediating the results towards your user, you are becoming responsible of that.
Yeah, unless
in some way.
Yeah, because I'm quite sure I'm not legal, so I never read the fine print of the agreement, but I'm quite sure the legal department of OpenAI or Microsoft or these big players is very good at preventing lawsuits. So they are probably going to be safe and put everything on your shoulder if you are intermediating their system.
At the same way, if you host on your premise a model trained by someone else, like an open source model or whatever, at the same way you are becoming responsible of everything is happening inside the model, but you don't have visibility, or at least you don't have full visibility of what could happen. So also this is a potential big risk for a company deciding to host the model by themselves instead of relying on terms and conditions of a third party that knows how they train the model. So this is something must be considered as well. Okay, I think for today we are done. So just to recap, we talk about LLM and privacy and sensitive data. How can you protect your company by exploiting sensitive data by the LLM? So the major suggestion are leverage LLM gateway and guardrails. This is a must in a LLM architecture. And also try to leverage RAG and fine-tuning as much as you can in the proper way. So RAG by keeping the sensitive data very well separated from the LLM. And when you do fine-tuning, instead leveraging synthetic data to do the fine-tuning, not use the real data to do the fine-tuning. And then we deep dive a bit in business aspects and legal aspect, ethical aspects. So we have seen how this is a really delicate situation that every company must deal with in the proper way. So pretty excited to see how this story will evolve. And thanks for coming today. See you to the next episode.
Thank you. Bye.
Bye.